So as you could see, like there are complex research questions. Choosing the right kind of analytical tools is really important to answer those questions. So one such powerful tool is Bayesian modeling. So what do you see the role of Bayesian models in healthcare AI, and how do they differ from traditional machine learning models? Could you give some examples of healthcare applications where Bayesian models have really shown advantages compared to traditional deep learning or machine learning models?
So the main power of Bayesian modeling is about creating custom distributions, right? So for example, let's put it this way. I want to, let's say, model a coin.
Yeah.
Right. One way to model it is simply as a Bernoulli distribution. Right. I know that coin can be modeled as a Bernoulli distribution. This is known to me. Right.
So like these are cases where we have prior information about the
prior
events.
information about the events. Now, the question really is, suppose I want to model a different type of a coin, right? A coin with a, let's say, I asked this in many interviews, so let us do this now. So a coin, let's say, with a memory, that means it remembers its previous toss, let's say.
Okay.
Right. So suppose I claim that I created this coin, and so I give it to you. Now model this coin in terms of a probability distribution. It's very much easy in a Bayesian setting. Way easier in a Bayesian setting than in a non-Bayesian setting. That's one of the way clearer in a Bayesian setting. Also, the causal graphs and all that I was talking about can be easily correlated or linked to a Bayesian model than a non-Bayesian model. So if I want to, let's say I know that F causes A, I can directly put a distribution on F and A and then link them together through some means, right? So for example, I can say that the mean of the second one is dependent on the first one and all that. So I can do a Bayesian learning on it based on, let's say, PyMC3, for example. Yeah. Right, PyMC5 now, right? So you could do that very easily. These are so Bayesian modeling is very, very fundamental. It basically is providing you with tools to model real problems. Right. So if suppose I were to give the same information to a deep learning algorithm without any Bayesian modeling, of course, Bayesian deep learning is available for us. We can do things there, but basically, suppose I were to give it a deep learning algorithm, or let us say a traditional algorithm. SVM, anything, right? So the moment I give it to the deep learning algorithm, I am actually not telling it anything about the probabilistic graph that is behind the scene.
Okay, you're saying it's more of black box kind of thing, is it?
Yeah, so it's more of a black box kind of a thing, even more than that, right? So it's not convenient to model it. It's not really straightforward to model it. How do I model, for example, that A causes B and then B causes C and C causes D? A also causes D. Let's say this is my model picture and model. There are 4 variables here, right? So now this connection between the variables, how do I? So that's why your multicollinearity becomes such an important problem in your regression and all that, right? Because there can be things that are correlated, but then there can be things that are partially correlated, right? Imagine you have large enough data set and you want to first find out what is correlated to what and all that. That itself is a big task. That itself is a troublesome issue, problem. So you have to, the causal structure is better represented through, naturally represented through Bayesian learning. So it's you have to, for non-Bayesian approaches, you have to do something unnatural about it, right? So I have this causal relationship I can naturally represent in the Bayesian learning. It's a straight problem.
Okay.